In this question, two functions f and g are given. So we have to find the composite functions f circle g and g circle f when they are defined. If these composite functions are not defined, we have to give the counter example. Okay. So now we can do the first question. Here given the one function f of x function is given. So this for this f of function well defined domain and codomain values are given. So other function g of x is given. For this g of x, so defined domain and codomain sets are given. Okay. So now we are going to check it. So this composite function, we know the composite function is more than one function. So we can form by circle. F circle g, we can say this is a composite function. Why? Because it is having the more than one function. So it is a composite function. Then it is defined or not. Now I am going to check it. This and that. So how can we check it? Simply the second function codomain value. Alright. So each function they are given domain and codomain values, right? For this function also defined domain codomain values is given. Okay. The function f of x, when we represent the domain codomain, we can write the f. F means function for this function domain and codomain. That is the meaning. Okay. So this is the composite function. So I am checking the defined or not. If the second function codomain value, what is this one? Z. Then which is belongs to or same for the domain of the first function. So this domain, this is the codomain, this domain. This should be the same or subset. Okay, same or equal. Z is equal to Z or subset also. Then only we can say that is a composite function is well defined. Okay. So now see in this question actually, so domain codomain for the first function, second function is given same. That's why so these two composite functions are compulsory defined component functions. That's why we are going to find the first we are going to find the this composite functions domain codomain. Finding out domain codomain is very important. Okay na? So if any composite functions, okay, domain value is nothing but the second function domain value. Okay, in the composite second function domain of the g which is equals to domain of the g. Okay, and in the domain of g which is given g function domain is z. Okay, z. The codomain of the composite function, how can you find it? Composite function f circle g. So codomain of the first function equal. Okay, codomain of the first function which is equals to the codomain of the first function f. In this way you can remember, which is valid for all composite functions. Whatever the functions, two functions or three functions, first functions is always giving the codomain of the total composite function. Last function is always giving the domain of the total composite function. So this is finding of domain codomain, but for composite function definition, the codomain set which is must be subset are equals to the domain. In that way you can check the defined point of view. But when you write the domain codomain, you can follow this one. Domain of the any composite function is second function. Domain of the any composite function is the codomain of the any composite function is the first function. That is important. In this way we can write the domain codomain for the composite function. Now we are going to find the composite function in terms of x. We know that composite function you take in the bracket. These two functions expressed in the x only, that's why we can also express this composite function in terms of x also. You take x. Now you can remove the circle, you can plug in the bracket to the g function. Okay. Now you close the g function brackets. Okay. Now in the bracket g of x function is there. That g of x already given the g of x value, right side term which is replaced by g of x. Okay na? Right side term which is replaced by, that's why it is replaced by mod x. Okay. Now f of mod x is there. We given the f of x function. So if you compare to this side, in place of x is mod x is there in left side. Similarly in right side also this mod x, we can substitute this mod x in place of this x. Then 3 into mod x minus 2 we got it. Similarly we can find the g circle of x. We can remove the circle and place the bracket for the function f of x, and this f of x can replace by the that rule, okay, right side formula, which is replaced by the f of x can remove and plugging this 3x minus 2 in place of f of x. Then after that you have to g of something is there, here g of x in place of x 3x minus 2 is there. Similarly right side also in place of x we can substitute, we can plug in 3x minus 2 here. That's why we got the mod of 3x minus 2. In this way we can do